Hello everyone and welcome back to Python 0. This is Cody, your host and your engineer. Now today I want to talk about something which is very important for scientists like me. It is mathematics. I will cover a lot of topics, how to do math in Python, and this is especially one of the biggest strengths of this language because it's everyone who knows MATLAB, it's quite famous. If you don't know it, yeah, you should know it. Google it instantaneously, I command you. No, MATLAB is very famous for having a very light math syntax, and yeah, it's the same in Python. They tried to copy it, and it worked out. Yeah, I would say it worked even out better. Now, there's something to say about Python and math is Python itself is pretty slow. Okay, so don't do stuff mathematics on your own. But there is a former Python library, and it's called Numpy. Usually I import it as NP, like everyone does. And behind Numpy are a lot of old, very high performant libraries, such as BLAS, LAPACK, and so forth. And I can tell you that no matter what you do, these libraries are highly tuned. So Python is merely a very comfortable wrapper for these high performance computing packages. And yeah, so use them. And use them especially with the NumPy arrays, which I will show now. Now, how to do math. So we had lists the last time, so 1, 2, 3, 4. And we can also do a second list like 4, 3, 2, 1. Okay, so let's say I want to add here entry for entry. Now, how to do this? Like when I, oh yeah, very nice. I gave both the same name. Now, what I want to do is usually in math I would just edit. Okay, so but it doesn't work out here because it just concatenates the arrays. And this is simply because you can think of a list more than of a mathematics set. It's not a vector. And how to fix this? Now, let's call it vec1, like vector1. And there is in NumPy the class which you should always use for vectors, and it's called array. And you can just drop in the list, and what you get is kind of like, it looks the same. You have just this array in front of it when you print it here. And yeah, with this vec, you can already, you can add it to itself, for example, and as you can see, it adds up the entries to one another. This is how everything is working, and the cool thing is you can also do, like, if you vector arithmetics, if you have a scalar here and you multiply it with this one, I don't know, let's take 0.1, you see it's working out. So it takes every entry of this vector and multiplies by 0.1. This is yeah, this is how it should be. This is how math should be. I tried math in a lot of languages so far, but I must say Python, in terms of math, it is uncrushed. Some libraries are good in C++ too, like Java is horrible for math, so I really don't like the libraries. But yeah, Java is not for computing, I would say. There are more different languages which I would recommend therefore. So let's start off. So we have this vector here, and let me just cover how you can build up these vectors. So like I say, what you can do is you can just do array of, I don't know, some list. What you can also do is yeah, if you already have a vector here and you just want to copy it, it's the same like with lists. Just drop in the second vector here, and yeah, it's a copy. The same accounts for every complex object. Here, when you do this one here, this is not a copy. Okay, this is not a copy. If you change this one will be changed too. So if you want to copy in the head of a function, use this array. If you just want to check if it is an array, but you don't want to copy it necessarily because it might be a large vector, you can just type as array, and if it is already an array, it's just transferred, and if it isn't, then yeah, it's just converted. Now, I already talked a little bit too much about detailed stuff. Now, you can also do something like zeros. So you create a vector with 4 entries and they are all 0. Okay, so this is very comfortable for building up large initialized memory. And what is also quite good is, I don't know, there's also ones. So all entries are 1. Also very, very comfortable. But this happens a lot. You have some value where you want to start, like 0 to 1, and you want to put, for example, 10 points in between, or let's do 5 because it's a little bit smaller. So this is literally start from 0, go to 1, and please put in 5 points in between. And as you can see, 0, 0.25, and so forth. It's working out nicely. This is I'm using this a lot. Very, very comfortable function here. Highly recommended from myself. So yeah, this is how you build up vectors. Let me just clear here, and yeah, you can do a lot more stuff and build it up, but I think this is most important. Yeah, one more thing to mention maybe. When you do something like this, zeros, you cannot only, like, if you do put in 4, oh yeah, I forgot to import it. Let's clear again. Damn it. Okay, what you can actually do is you can already, like, if you want to build a matrix with zeros, when you put in here a 4, you have 4 entries, and as you can see, okay, it has the length 4. But what if you want to create a matrix, like a 3 by 3 matrix? You just put in a tuple here, and it has 3 by 3. And as you can see, it's a 3 by 3 matrix. Very, very comfortable. Is working out pretty well. Awesome. Now, let's continue this. There is a lot of stuff I want to show you. Oh man. If you want to have some random number matrix or vector or whatever, just call numpy.random.random because there are more than one random type, and it creates uniform random numbers. And if you put in, like here again, 4, you have these 4 entries, and if you put in like 2 by 2, you get a 2 by 2 matrix with random entries. Also very helpful if you need just some test data. We will use it later for a more advanced example. One of the let's call it one of the very strong features is actually how to handle this data. So now let me create a matrix by hand. So let's do 1, 2, 3. No, let's do 0, 1, 2, 3, 4, 5. So it is not an even matrix. Okay, so you can check the shape of the array or the matrix by v.shape, and you see it's a 3 by 2 matrix. Now what I want to show you is how slicing is actually working. So you can like in strings, you can say, okay, I want to have row number 0 to let's just say I want to have row number 0, and you get the 0, 1. Okay. You can also say I want to have row 0 to 2. Remember, this is exclusive, so we will only see 0, the first and the second row. Now, let's say I just want to have the first column here, and this is what is really, really awesome. Let's just say, okay, we take all rows, but only the first column. And as you can see, you get it out 0 to 4, 0 to 4. Very, very strong ability to slice here. And what do you get out here when you do this slicing here? It is not a copy, okay? NumPy doesn't create copies here. It just creates, let's say, another view of what you're using here. So if you change here, this will be changed too. Very, very important, because this can lead to a lot of memory bugs. Like I said, every complex data object usually is not copied. You just pass on the reference in memory. Now, there is maybe, the most basic operation. If you have, I don't know, a matrix like 1, 2, 3, 4, which is funnily almost our matrix, not exactly, and you want to just multiply it by some vector, like 1 or 2, I don't know. This would be 2 by 2 would be 4. Let me just multiply it. Oh yeah, that was a sexy bracket again. I'm very talented in this. So this is a 4 plus 1. Actually in the first row. So you just do 2 by 2 plus 1 by 1, and in the second row you do 2 times 4, just for the guys who are not. You should know how to do this. If you don't know this, you're not a good engineer. Okay, okay. 2 by 4, and then you do 1 by 3, which is actually just 3. And what we should get out is 411. Yeah. So let's just exactly do the same. Let's build up the matrix A. Yeah, let's use no, in programming you don't use large letters for instances. Usually you use it just for classes. So 1, 2, and let's do 3, 4. Yeah, here we are. And let's do a vector 1, 2. So we have both. Now what will happen is A times V, you see it doesn't work. It outputs something, but it's not what we expected. And actually A is 1, 2, 3, 4, and what comes out here is 1, 4, 3, 8. So what happened is this column here was multiplied by this one, and this column here was multiplied by this one, and this is not what we want to have. You see this multiply symbol here, it's more like multiply each entry with each entry if possible, and otherwise it tries to find a route to solve this problem. But what you want to do is you want to use a dot product here, the classical dot product. So how to do this? Now there is just the dot product function in NumPy, and as you see we get out 5, 11, which is exactly what we want to get. So we multiplied A with V, and what we got out was the 5 and the 11. So yeah, I'm quite happy currently that it worked out, because I had so much fear that I was wrong here. It's rather a spontaneous example. Yeah, okay, sometimes you have to get cocky and be spontaneous, but yeah, you have to live with the risk, but I think I can deal with it. Now, this is how math in general works. The dot product should resolve most of the problems which you have. There is Einstein's summation and a lot of features. One of my most favorite features is inversion of matrices. But I think for basic stuff we will use it in the next tutorial for plotting, because this is awesome. You need a little bit of math for great plots. So let's continue with another example. I want to show you how powerful actually it is. So let's solve some very simple and frequent task. Many people use complicated programs for what I'm doing now, but I say we can do it without any complicated program. So let's start free off. Let's say we have a vector from 0 to 1 with, I don't know, 100 data points. No, let's do 500 because we actually don't care about memory here. So let's say we have some data like it's x plus some noise. No, let's use a normal distribution with mean 0. Yeah, I don't know, 0.1 standard deviation, and also we need 500 samples, otherwise it won't work. And just ignore my plotting here, because this will be for the next video actually. But I want to show you the data, and it doesn't work if I don't show you some plotting functions here, but forget them. So this is the data. We have a linear curve. This is like test data from real world, and you wanna one of the most frequent tasks, you wanna use regression to put in a line. Okay, just put in some line through these point clouds and get out the equation. This is like 80% of an engineer's task is regression. And so we will solve this here very, very fast, and I want to show you how to do this. Now, first let's do the math. We have a linear equation, which is just a0 times x power to 0 plus a1 to x power 1. Oh yeah, that was a good one too. No, it's better. And this is just some value y. Now, this cancels out to 1. And as you can see, this is just a linear equation. Now, what we want to get out is we want to get out these a's. Okay, so they're the targets. And it's really, really simple, because in school what you learn, you have two unknowns, so you need 2 points just to solve it. You know, you just drop in a0 times plus it was right, plus a1 times some value x1, which is out of this x array. Let's just say we have some point at 0, and let's say it has the value, I don't know, 0.1. So this is the first equation, and we can use a second value like I don't know, 0.4, and it should be around 0.4 there. Let's just say that there, because of the noise, it's 0.5 whatever. So as you can see, we have 2 equations and 2 unknown, and you can just wrap it up as a matrix equation. And what you get in here is not the a's. I was wrong here. Let's just say these are the xi's. Okay, so what you get in here is x power to 0, and what you get here is x to the power 1, and the same here. So you get this matrix here, and well, what was wrong with me there? Just wanted to leave to the right. Yeah, you know, we do brackets differently now. So what you have in here are the a's. I try to speed this up, but I'm really, really bad. And what you need on the other side are the y's of the points. So here you have y0, and here you have y1. So we have to solve this equation. So this is some matrix A. This is some, no, not some matrix A, some matrix X. And this is some vector A. And this is some vector Y. And what you want to do is, for getting A, you usually invert it. So was I just telling you the wrong thing? I don't know. I cannot remember. Sometimes when I'm in my mind, I totally forget what I was telling, or swap stuff like I had it usually in mind. Now, you invert x, and then you dot it with y, and then you get the a's out. So you need to invert this matrix here, and multiply it with this vector, and then you get out the a's. So this is the equation. Now this works only if you have, you see here, we have two unknowns and we have two equations. Now the problem is our x has 500 points. It's much larger, and how to deal with it? For this one here, there is the called the inversion function in Numpy, but what you can actually do is you can generalize this by calling a function which is called a pseudo inverse of a matrix. And what it does is it's a little bit confusing in the beginning. You can look it up how the pseudo inverse matrix is calculated. It's very simple. Just some simple style math. This one is included in this one. Like, this is a generalization of the inverse of a matrix. Now what happens is you need to the inverse of the matrix X here solves this problem of solving the equation. Now if you have more than like an overdetermined equation system, you need to use the pseudo inverse, but then it will work the same way. You have more equations than parameters, but you get out like the best a's which you can get. And we want to exactly do this one here now. We want to solve this equation. Now we already almost have the data. We need to build a matrix X. Okay, so I will just show you how simple this can be done. We need a matrix of ones, and let's just say, okay, we need in times of rows we need the data. So let's just take length of X, and we need 2 columns, and yeah, and we need to set the all rows, but the first column to X. Oh, that was rather unlucky. Oh no, I totally screwed up. Shame on me. Now I wanted to use large X, which is actually, yeah, let's just see here. So we can go forth and just say, okay, we put this to X. And what actually happens, I show you a slice of, I don't know, 5. Oh, let's do 4. That's more than enough. The first column is actually 1, like here. And the second column contains all of the x's. Now you can also put a parabola, but then you need a further column with x squared. But that's a topic for something different. Now we have the matrix X, we have Y. Now we want to calculate b. So what we want to do is we want to call numpy dot because we need to dot it, and we already know what to drop in here. It's the y vector, but here we need to call the pseudo inversion of a matrix, and this is really fast. By the way, use this function. Never do pseudo inverse by yourself. These functions here are, like I said before, highly optimized. You won't make it any faster in Python. Not really. I don't think so. Maybe in Fortran or something like that, but not here in Python. Now you just call the x plus, and then you just dot it, and you get out the a's. As you can see, we have 2 parameters. Now let me just show you. Have I still? Yeah, I still have the data here. So let's just call this getter plot, and let's just call x, and then we need to do the equation a0 plus a1 times x, and this is exactly the equation here which we have here. Okay, and we just want to see where our line goes through. Now let's just plot it in the red line. And maybe we should use a line width larger, maybe 4. So let's just show this. And yay! You cannot see it yet, but it's worked. Like, this is our point data, and we have put in here a very straight line. And this is one of the most frequent tasks, and in other languages you need a tremendous amount of code. And just see here, with everything I tried in error messages, you can wrap it up in a few lines. It's really nothing. Like, building up this matrix X is no issue at all, and then you just need one line for solving it here. And this is why I want to show you how powerful Python math is. It's more powerful because it's short. It's very, very short and intuitive. And this is extremely strong. So yeah, do stuff like this if you wanna do. I really like. I use a lot of regression and stuff like this, but I'm also yeah, I'm using machine learning, and it's all about prediction, and therefore you need regression. Now, if you have any further topics, the next one will be plotting, because this is only the beginning here, such plots. I want to show you how to use really, really awesome plots, and you can do a lot of stuff which I haven't been able to do in other languages yet. So there are a lot of possibilities there. See you next time.